Hi everybody. In this video we are going to discuss what is a linear equation. Suppose we have an equation y equals 2x. What does it look like? Let's try to draw a graph. And to do that, we have to draw some points using this equation. But how do we do that? Well, let's pick some values of x and some values of y, and then hopefully we can use those values to draw a graph. Now suppose we choose x equals 1, then what's y? Well, since y equals 2 times x, I hope you agree that 2 times 1 becomes 2. So if x equals 1, y must be 2. Similarly, when x equals 2, what could be y? Well, again, y equals 2 times x. So it will be 2 times 2 and y will be 4. And so on. So we can sort of have a few x and y pairs. Now next comes the task of plotting them, because remember we wanted to see how does this equation look like if we physically drew it. So we draw an x-axis and a y-axis, and then we still have to draw the points, although the points are there already for you, but I'll show you the process. So that how did we get to that? So suppose we want to draw our first point, which is 1, 2. X equals 1 and y equals 2. So we go to the x-axis and find where x equals 1 and draw up a line. Correspondingly, on the y-axis, we find where y equals 2. Remember, in the first row, x equals 1 and y equals 2. So we find that point and we do y equals 2. Now, the place where these lines meet, we put a point. So that is why this circle appears there. Similarly, for the next point, we read the second row from the table. Now x equals 2, so we draw up a line from x equals 2. Correspondingly, we draw a line from y equals 4. And again, we leave a point at the spot where the two lines intersect. And by repeating this process, we get all the other points on screen. You can pause the video and practice plotting those points yourself. Now what do we do? Well, let's join all the dots and see what appears. And what appears is a straight line. Hence, y equals 2 times x is a linear equation. And to get a hint, the word line appears in the word linear. This is why I have color-coded line at the top of the slide. Now, note when choosing x-y pairs, we chose the values of x ourselves and picked any values we liked, freely or independently. Therefore, we call x an independent variable because its values didn't depend on anything else. In contrast, we didn't choose the values of y ourselves. They were computed from the equation y equals 2 times x, and they depended upon the values chosen for x. Therefore, y is a dependent variable. Note, y equals 2x is not the only linear equation in the world. There are many others. For example, y equals 2x plus 2 is also linear. But how do we confirm that? Well, to confirm that, we can repeat the drawing process again. So we have to choose the values of x and compute the values of y. Now, to simplify the process, let's reuse the same old values of x. Although that's not necessary, it only, like I said, only simplifies our slide here. So we reuse the same values of x, 1, 2, 3, and 4, and correspondingly find the values of y using this new equation. I hope you can work it out on your own, but these are the values. So you can pause the video and stare at the difference between the new values and the old values. I hope you can spot that the new values simply are 2 more than the old values. This is also what the equation said as well. The equation is y equals 2x And y equals 2x is the same as the old one, but the new equation also has a plus 2 in it. So the new equation simply added 2 more to the old equation. Hence, all the y values are also 2 more than the old y values. So how does this look like graphically? Well, as we can see, it's still the same old line, but only one that has been moved up 2 places. Now note also where the new line touches the y-axis. It is at y equals 2 where it touches the y-axis. Whereas for y equals 2x, which was the old equation, that line touched y-axis at y equals 0. You can pause the video and rewind it to reconfirm that. Now, these facts that I've just mentioned, we'll come to them shortly as well. Now, similarly, y equals 2x minus 2 is another linear equation. And how does that look like? Well, I hope you can guess that this will still be a straight line. But just like y equals 2x plus 2 moved up 2 places, y equals 2x minus 2 will move down 2 places. So, and that's what is shown here. Yeah. So can we give a general form of linear equations? I mean, is there something that we can generally say? What does a linear equation look like? Well, yes. The general form of a linear equation is y equals mx plus c. And you may be wondering what m and c are. Well, in y equals 2x plus 2, m is 2 and c is also 2. Whereas in y equals 2x, m is still 2, but c is missing. So we say c equals 0. So what is the impact of changing c? Well, we've already seen that. Changing c, it can either move the line up or down. And this also decides the point where the line crosses the y-axis. Hence, c is also called the y-intercept. So you can pause the video here and practice redrawing the lines with different values of c to see its impact. You may, however, be wondering, what is m and what is its impact on a line? Well, that's what is coming next. So let's discuss the slope of a line and the impact of using m. So we start with a simple equation y equals 2x as before. Here are the xy pairs as computed earlier, and here is its graph. Now let's change m from 2 to 3. So we now have y equals 3 times x. Let's draw up new pairs of values for x and y. Well, for x, we reuse the same old values 1, 2, 3, 4, and correspondingly we evaluate the values of y. So here they are. So you can pause the video and evaluate yourself that the values of y have now grown bigger, as we would expect, because y is now 3 times x, not 2 times x. So when we draw the line, it looks like this. Now the starting point of the 2 points is still the same, because if we consider at x equals 0, y equals 2x and y equals 3x both produce the same value, that is 0. So the starting points of both those lines are 0, 0. Similarly, for y equals 4x, here is the line. You can self-practice, and I recommend you do practice it by plotting these points yourself by drawing up a table as is seen on your screen as well. So in general, I hope you can see a pattern emerging. As we increase m from 2 to 3 to 4, what is physically happening is that the slope of the lines that we see are also increasing. Whereas if we read the numbers in reverse, like we go from y equals 4x back to 3x and back to 2x, we start following these lines, we can also say that decreasing m decreases the slope of the line. Now you may be wondering, is slope always a positive number, or m is always a positive number. Not necessarily. We could also have a negative slope. For example, y equals -2 times x. And again, I'll leave it as a task for yourselves that you draw up a table and draw the line. And you can compute the points, and you can expect that the y values will be the same as y equals 2x, only this time with a negative sign. So therefore, this line that you draw will have a downward slope. Hence, negative m gives negative slopes. And if we make it more negative, like -4, -5, or -6, the slope will become even steeper, only facing downwards. And to wrap it up, another keyword. Slope in maths is called gradient. Remember that? Practice drawing these graphs, and I'll see you in the next video. Thank you.